Welcome to today's session on organic reactions. We are going to be looking at addition reactions in specific, and just to remind you or to let you know, organic reactions, an addition reaction is a reaction in which small molecules attach itself to a carbon-carbon double bond, so an unsaturated molecule, in order to form a saturated molecule, which then has those bonds to it, so we change in the functional group. In general, when we look at this, what that means is we will have a double bond between two carbon atoms. We're going to have something that doesn't have, it can have a double bond, but we have another molecule, another compound, which we then add. That double bond breaks. When that double bond breaks, it creates a space for the atoms of the molecules we're trying to add, which then changes it from a unsaturated hydrocarbon to a saturated hydrocarbon. So, there are several types of organic reactions, and that's what we're going to look at now. So the first one here is we're going to look at hydrohalogenation. Halogenation, halogen, which means we add in a hydrogen halide. Remember, X can be bromine, chlorine, iodine, or fluorine, any of the halogens. Important for this reaction to take place, there mustn't be any water present. Best thing to do, let's look at some examples. So we start with the reaction between ethene and hydrogen bromide. We're going to do this in structural formulas. Ethene, C2H4. All right, C2H4. We add in it to hydrogen bromide. What's going to happen is the double bond becomes a single bond. Both carbons keep their original two hydrogens, and the H goes to one carbon, and the bromine goes to the other. Now it doesn't matter which one it goes to because it's the same. So we're starting because we get the same product. So we had ethene, and now we have bromoethane. All right, straightforward. But what if there's a choice? So if we look at the next one, so we've got the reaction between propene and HCl. Once again, we're going to start right at the beginning. Propene, 3 carbons in the longest chain, 2 hydrogens, only 1 hydrogen on the middle one, otherwise the carbon has too many friends, can only make 4 bonds. And of course now we have HCl. What will happen here now is there's an option. There's actually 2 things that could happen. C. The third carbon still has 3 hydrogens to it. That's not going to change. It doesn't matter if it goes up or down. This one's still going to have 2. Oh, sorry about that. Let's just, there we go. Now we've got a choice. Where does the hydrogen go? So either that hydrogen can go to the second carbon and the chlorine can go to the first one. That creates 1 chloroethene, okay? Or, and this is my other option, so the last carbon still has 3. That's not going to have changed, all right? First carbon still has 2, but now this is the difference. The hydrogen can go on the first one, the chlorine can go on the second one. Both of those are valid products. One is called a minor product, one is called a major product. Major product is what we would get most of the time. And when I ask you to give me a product, I expect the major product. So which one is it? It's this one. Okay, how do we know? Because we have a rule that says to us, and it's known as Markovnikov's rule. Okay, you don't have to know it states it, you just have to be able to apply it. When an unsymmetrical alkene, such as propene, reacts with a substance, HX, the hydrogen atom adds to the carbon atom that has the greater number of hydrogen atoms, and the X goes to the carbon with the fewest. So what this means is hydrogen likes to be with the carbon that has the most hydrogens. Hydrogen wants to be around other hydrogen friends. That's really what we're saying. So when we add the hydrogen to the first carbon, we do so because there's already 2 carbons attached to it. The second carbon only has one hydrogen. So this hydrogen likes to be with more that look like itself. Okay, it's one of those things. So we know the hydrogen goes to the carbon with most number of hydrogens already attached. So we always draw the major product unless we're asked for the minor product as well. Now, next equation. Write an equation for the reaction between but-1-ene. So we've been told exactly which hydrocarbon we have. So we've got but-1-ene, but 1, 4 carbons. Okay. Hydrogen, only one hydrogen on the second carbon. There we go. There's our 4 carbons. They say to us it's been added to HBr, and they want to know what we get at the end. Now, they tell us, write an equation for the reaction between but-1-ene and HBr, show the reaction using structural formulae, also show the reaction. So they really want a proper chemical reaction as well, which we'll get to in a second. Where does the bromine go? Because now this is the key here. So we have 1, 2, 3, 4. All right. The third carbon still had 3 hydrogens. The third one should have 2 there. So the third one still has 2. The second one has 1. And the first one has 2. So where do we put the hydrogen and the bromine? Well, looking at Markovnikov's rule, the hydrogen goes onto the carbon with most number of hydrogens, and the bromine goes onto the other one. So in other words, we now create 2-bromo-butane, but they wanted it as a reaction as well, so we need to write it as a molecular formula as well. So we've got C4H8 plus HBr, which then becomes C4H9Br. Nice and simple. The same rules apply every single time we do this. Next one is halogenation, which means we're just adding in halogens. Okay, you should have seen this when we were looking at test for saturation. The important thing here is we're using X2. Halogen gases condition needs to happen at room temperature. So we start with the simple one. We've got ethene again, like we started before. We're going to add it. We're going to add chlorine to it. That means that each carbon gets a chlorine, and we end up with, remember, this is quite important, so here we're going to end up with 1,2-dichloroethane. The chlorines go on separate carbons. If we look at C3H6, now they've given us a molecular formula. It doesn't matter. Okay, molecular formula, because, oops, maybe I should use a pen that you can actually read. How does that sound? Alrighty, so C3H6, but here we don't need to make a choice as to where the bromines will go in each of the carbons that were attached to the carbon in the first place. So Markovnikov's rule that we used earlier, not important, because what's going to happen is that double bond breaks. Alright, please remember you need to draw these all in one nice straight line. BR, BR. Okay, good. So, what about hydration? Now we get into the ones that are a little bit more complicated. Now, please, we're going to look at reactions where we add water again a little bit later on, which isn't called hydration. Hydration's nice. You drink water, you hydrate. You add in water. If we add water to an alkene, we get an alcohol. I need you to take note of something, though. We have to have a catalyst. That catalyst is a dilute strong acid, either sulfuric acid or phosphoric acid. I'm just going to stick to sulfuric acid because it just makes it easier to stick to the same one the whole time, but it really doesn't matter. But it is an catalyst, which means you must put it on top of the arrow every time we do this, all right? So, starting with the first one, we've got the reaction between ethene and water. Okay, ethene, we all know. We should hopefully be able to draw things like ethene in our sleep now. So we have ethene. We're going to add it to water. I'm showing all the structural formulas. Please, you need to remember that it is a bent structure. Now, this one's easy. It's a symmetrical molecule. The double bond breaks. Okay, each carbon had 2 hydrogens. But how does this break up? Well, the one's going to get a hydrogen and the other one's going to get the OH. Remember, that's how it's going to break up. We're going to have H and OH. Very, very, very important here. What if things are a little more difficult? Okay, so now, here I have C4H8. I haven't been specific as to where I want the double bond here. So this could be 1-butane, a but-1-ene or but-2-ene. Let's stick with the easy one and make it but-1-ene. Okay, but-2-ene, it wouldn't make actually a difference for the reaction as to where the OH goes. So we're going to do it with but-2-ene. Okay, so here we go. But-2-ene, C, there's our 3, hydrogen, 1 hydrogen, still H2O. And we're going to do the major product. So we know the double bond's gonna break. All right, so we know we are going to create butane. We know that this one's going to have 3 still, that's going to have 3, that's going to have 3, this one's still going to have 2, this one's still going to have 2, that one's going to have 1, still 1, and 1. The decision we have to make is where does the OH go and where does the H go? Remember Markovnikov's rule, hydrogen goes to the carbon with the most number of hydrogen atoms already. So it goes there and we create a secondary alcohol. So we create butane 2O. Okay, great. What about hydrogenation? Now, hydrogenation is actually a very important reaction for us because with hydrogenation, this is a reaction that we use to create margarine. Okay, it's a way for us to harden plant oils, to harden fats. When we look at hydrogenation, adding hydrogen. Now, what's important? We have to have a catalyst. Nickel, palladium, or lead, platinum, stick to one. Learn one, stick to that. That's the one you put in every time. And we dissolve the alkene in a non-polar solvent like carbon tetrachloride. It makes the reaction happen a little bit faster. Now, the nice thing about this is all we're doing is adding hydrogens. So we don't need to worry about any rules as to whether it's going to go from but-1-ene to but-something-2-ene or whatever, because it's literally going to go from an alkene to an alkane. So if I had butene to start with, I'm going to end up with butane at the end. Very, very simple. This is a nice one. So C2H4. All right. We're going to add it to hydrogen. All that's going to happen now is the single bond gets created and we had ethene. Whoops, I forgot the platinum. And now I have ethane. Very, very, very important. Let's look at one where they ask us a little bit different. They say, write the equation for the reaction between but-2-ene and H2. So but-2-ene, all right, but-2-ene would be C4H8 plus hydrogen, which then means it's going to become C4H10. Okay, don't forget your catalyst. So but-2-ene means it's got to go on the second carbon. Oops, I'm about to not leave myself enough space. There we go. There we go. Remember, whether the hydrogens go up or down doesn't make a difference. We're going to have H's, and all that's going to turn into is butane. butane. So we started with butene, and we've ended up with, because this was the question, name the product, we've ended up with butane. So we've gone from a double bond to a single bond, and we ended up with the easiest. And hopefully you now have a little bit of a better understanding about addition reactions. Rewatch this if you need to, and hopefully it made sense. Thanks, guys. Welcome to this session on organic reactions. There are 3 specific types of organic reactions: addition, elimination, and substitution. And what we are going to look at today is addition reactions. Whoopsie.